Unit 10, Day 5. Inverse trig composites. Sounds fancy, but it's really not that bad. Yes, sir?
Is this going to be similar to the problems that are kind of like f of g of x? Like where you solve the first and then you solve it based on the answer?
I hadn't thought of that, but yeah, it's not phrased like that, but that is a composite where you do the inside first and then do the outside. So it very much, it is like that. I hadn't made that connection, but that is absolutely correct. Because I was just going to describe it as sort of nested trig problems. Like you got to do the inside to get to the outside, which means that it's exactly like those composites. And so we already know everything we need to know. We're just going to do some examples. And the notes I found or have, there's like 20 examples. I'm like, we don't need to do 20 examples. Like it's because we know the stuff. We just need to know how it goes together. And because we know the stuff, there's no new concepts to know. We can just jump right into the new problems and see what they look like. And sort of in the process of doing new problems, we'll kind of get a review of most of the stuff that we've done. So number one, the sine of the arctan of square root of 3. So maybe that looks ugly, but just start on the inside. Arctan of root 3. Tangent comes from first or fourth. Or it doesn't matter, it's positive, so it's coming from the first. Now, arctan of square root of 3? Pi over 3. This is where the tangent 3 trick really helps. The answer has 1, 3. The angle has 1, 3. So arctan of square root of 3 is pi over 3. And then the sine of pi over 3. The sine of pi over 3? Root 3 over 2. So there's really nothing new today. It's like you've done nested problems before. You've done unit circle stuff before. We're kind of just putting it together so it serves as a review. It's really what's going on. It's just a nice review day. Problems should go quick if you know unit circle. In fact, speaking of knowing the unit circle, find some volunteers for some of these. Tangent of the inverse cosine of negative 1 There's a dynamic duo for you. Audrey, where is the cosine equal to negative 1?
Pi.
Yeah, good, pi. And Danny, we already have our picture drawn there. Maybe that will help.
0.
Tangent of pi, y over x is 0. Good. Again, it's just nested problems, which I guess means it doubles your chances of making a mistake. But go slow, draw pictures. Arctan of the tangent of 7 pi over 6. Arctan of the tangent of 7 pi over 6. All right, Cole, how about the tangent of 7 pi over 6? It's okay. Tangent may need to slow down and do the y over x thing.
Root 3 over 3.
Root 3 over 3. Was that from the tangent 3 trick, or was that because you did y over x?
Tangent 3.
Yeah. So if there's a 6 in the denominator, you're going to have two 3's in your answer, right? It takes 2 3's to get to 6, so 2 3's in your answer. Cecilia, the arctan of root 3 over 3. So where is the tangent equal to root 3 over 3? What's that? I mean, it's got to be over 6. The angle's got to be over 6 because there's two 3's. Pi over 6. Some people that kind of messes with their brain because arctan and tan are supposed to undo each other, and yet the arctan of the tan doesn't get you back to where you started. It's a little bit like, what's the square root of negative 3 squared? So you tell me, what's the square root of the square of negative 3? 3. Not negative 3. You square the negative 3 and you get positive 9, and then square root it, and it turns it into a positive 3. It's kind of the same thing here. You can't just say that they cancel each other out. You got to slow down and see what's happening there. Arc cosine of the cosine of 2 pi over 3. And again, the best way to work these is not to think about whether they cancel each other out or not, but to just work the problem. So Evan, what's the cosine of 2 pi over 3? There's 2 pi over 3. Cosine means, am I looking for the x or the y?
X value is 71 half.
There you go. Positive or negative?
Negative.
Negative because it's backwards. So the cosine of 2 pi over 3 is negative 1/2. JD, what's the arc cosine of negative 1/2? Where is the cosine negative 1/2?
Pi over 3. Or is it negative pi over 3? Not either.
There's pi over 3.
Yeah.
There's negative pi over 3. The cosine of both of those is a positive.
So it's
So it's definitely over 3. You got that part right.
So it's is it 2 pi over 3?
Yeah. I mean, you have two options, but only one of them is the best option. It's 2 pi over 3. So that is one where they did cancel each other out. So that's a little bit more like, what's the square root of 3 squared? Well, it's 3. But so you can kind of go through the rules of when do they cancel each other out and when do they not. It's really not worth thinking about. It's best to just work the problem. Let's do one more of this type, and then there's one other type of problem. The inverse tangent of the cosine of 0. The inverse tangent of the cosine of 0. Luke, what's the cosine of 0? 1. Good. And then Brandon, the inverse tangent of 1 means what angle has a tangent of 1? What angle has a tangent of 1? This is where you got to know your unit circle. So somebody help him out. Where's the tangent equal to 1? 45 degrees, where the y and the x are equal to each other. So pi over 4.
Why does cosine of 0 equal 1?
Because 0 is right here, right? And cosine is the x coordinate. So the cosine of 0 is 1. Oh, I meant to label that Roman numeral 1. Two types of problems. The unit circle problems you have to know the unit circle. Again, if you need to take your unit circle on another date to Sonic and spend some quality time with it, then do what you need to do. Roman numeral 2, I'm just going to call picture problems. It's really anything that's not on the unit circle. But the good news is, if you don't have the unit circle, you can still get these problems, right? The sine of the arc cosine of 3/5. Sine of the arc cosine of 3/5. So 3/5, like I don't remember a 3/5 being on the unit circle. So you just have to recognize that, wait a minute, that's not, like I know the unit circle values, 1/2, √2/2, √3/2, plus or minus. There's no 3/5 on there. So this is not a unit circle problem. So let's back up. Cosine, what was the first thing you learned about cosine? Like way back in geometry, what did you learn that cosine was?
Opposite over hypotenuse.
Wait, that's sine. You got to write out SOHCAHTOA to figure it out. Adjacent over hypotenuse. That would be another way to classify these problems. These are SOHCAHTOA problems. So I'm just going to draw a triangle where the adjacent is 3 and the hypotenuse is 5. Let's see. I guess I can reasonably draw it to scale. Oops. Adjacent is 3, hypotenuse is 5. There's my angle. So I don't really know what that angle is, but I don't need to know the angle because, right, so if it asked me for the arc cosine of 3/5, if it stopped there, I don't know what that answer is. That means find the angle, and I'm like, well, there's the angle, but what the value is, I don't know. But it asked me for the sine of that angle. I'm like, oh, well, I do know the sine of an angle. That's opposite over hypotenuse. So what's the opposite? 4. It's a good old 3, 4, 5 right triangle. So 4/5. Switch things up a little bit. The cosine of the arc sine of -1/3. Cosine of the arc sine of -1/3. Again, 1/3, you're like, wait a minute, that's not on the unit circle because I know the unit circle well enough to at least recognize values that are there. That's not on there. So then my brain has to switch to SOHCAHTOA type things. Sine is -1/3. Thank you. So let's see, opposite's -1. So I'm going to go down 1. Hypotenuse is 3. I think it's helpful to still put these on. I didn't do this on the first one. I probably should have. It's helpful to still put them on a plane, kind of like the unit circle is. I think that helps with the positives and negatives. Arc sine of -1/3. Okay, so we're talking about this angle. I don't know what that angle is, but the cosine is adjacent over hypotenuse. Hypotenuse is 3. That part's easy. Adjacent, how am I going to find the adjacent? Yeah, a squared plus b squared equals c squared. So 9 minus 1 is 8. The square root of 8 is 2 square root of 2. So 2 square root of 2 over 3. So the second half problems, again, are SOHCAHTOA problems. They're not unit circle problems. that was all sines and cosines. Let's tricky it up a little bit here. Throw in a cosecant of the inverse tangent of negative 12/5. Again, it's the same process. It's just harder because it's tangent and cosecant, and it's negative. Cosecant of the inverse tangent of negative 12/5. Okay, what quadrant am I going to draw my picture in? If the bottom right. If inverse tangent has got to come from 1 or 2, so I'm going to draw it in the bottom right. So let's see, and then opposite over adjacent. I'm kind of trying to draw it to scale. I want my opposite to be longer than my adjacent. Opposite's negative 12. The adjacent is 5. And then cosecant. Cosecant goes with sine. Sine is opposite over hypotenuse. So I want hypotenuse over opposite. And as always, you don't have to write all that down, but that's what your brain is thinking when you see cosecant. It's like, flip the sign. So flip O over H, and I get H over O. So I got to find H. Anyone know H without having to do A squared plus B squared equals C squared? 13. Because there's some Pythagorean triples that are helpful to know. If you don't know them, then you end up doing Pythagorean theorem, and that's fine, you get them. But these are some common Pythagorean, if I can spell, triples. They also like to show up on ACT, SAT type stuff, because they know that you can figure them out if you need to, but if you know them, it saves you a few precious seconds when you're working through those standardized tests. So 5, 12, 13, so the hypotenuse is 13, so 13 over negative 12.
What's the third number on the Pythagorean?
Sorry. 3, 4, 5, 5, 12, 13, 7, 24, 25. There are others, but those are the common ones. Well, use the word common kind of loosely there. Don't know where you'll see them outside of a geometry or pre-calc class. Let's do one more of these. Let's do the sine of the inverse cotangent of negative 24 over 7. The sine of the inverse cotangent of negative 24 over 7. So what quadrant are we going to draw this picture in? Cotangent has to be in 1 or 2. So inverse cotangent means I've got to be in quadrant 1 or 2. So it's negative, so it's going to be in quadrant 2. Let's see, cotangent is adjacent over opposite. So adjacent is 24. Opposite 7, and the 24 would have been negative because it's going backwards. Sine is opposite over hypotenuse. What's the hypotenuse? All right, we just did this one, or we just talked about that. 7, 24, 25. If you forget them, then you got to go write down 7 squared plus 24 squared. Take the square root of that, and you get 25. So 7 over 25. All right. Again, that makes today pretty much all review stuff. We haven't done that type of problem, but we've done all the pieces of that problem. So today's assignment is worksheet 5, and it's another one of those where if you know the unit circle, it goes really quick. If you don't know the unit circle, you're going to be kind of spinning your wheels. Just a heads up, tomorrow will be worksheet 6, will be the assignment, so I'll be happy to take questions on it. So you've got the rest of today, that's 20 minutes or so, all of tomorrow to make sure you're up to speed and ask questions. Okay, again, I don't have a tutoring time before this test, but that's why there's a built-in review time. So use your time wisely today and tomorrow to make sure you're ready for the test on Wednesday.
What does a test compose of? Like, how many questions?